All right, we're going to look at comparing relationships with tables and just see if we can tell if they're proportional or not. So just to get warmed up, kind of thinking about proportional relationships. We've got a lemonade recipe. First two questions, we need to keep it the same proportion so it tastes the same. But it does need to have different amounts. So one that would make more lemonade but taste the same as the original. So we find a scale factor that we're going to multiply each of the ingredients by. So let's do 1.5. So 5 times 1.5 is going to be 7.5. So that would be lemon. 2 times 1.5 is 3. That would be water. And then 2 times 1.5 is going to be 3 as well for tablespoons of honey. Okay, that would make it make more, but the ratio should be the same, so it should taste the same. Likewise, the second one that would make less lemonade, but taste the same as the original. So if we have a scale factor of 1/2, so half of 5 is 2.5 lemon. Half of 2 cups would be 1 cup of water, and then half of 2 is 1 tablespoon of honey. Okay, next one that would have a stronger lemon taste than the original recipe. So obviously we want to increase just the lemon, so it is a stronger lemon taste. So let's just say we use 7 lemons. We can stick with the 2 cups of water and 2 tablespoons of honey. Right, that's going to have a stronger lemon taste, but it's not going to be much more than the original recipe. Okay, one that would be a weaker lemon taste. So if we used 4 lemons, still use 2 cups of water and 2 tablespoons of honey, that would be a recipe that would be weaker. All right, so we have 2 that are proportional, that the scale factor changes by the same factor, and 2 where it does not. All right. So now we're going to take a look at a table here, see if we get a proportional relationship here. And this one just says the entrance to a state park costs $6 per vehicle plus 2 per person in the vehicle. So how much would it cost for 2, 4, or 10 people in a vehicle? So we can fill that out. So we know that it's 6 plus 2 times the number of people. So in this case, it's 2. That's going to equal, so 4 plus 6, which is 10. 6 plus 2 times, now there's 4 people, which equals 8 plus 6, which is 14. And then 6 plus 2 times 10 equals 26. Okay, it says for each row in the table, if each person in the vehicle splits the interest cost equally, how much will each person pay? So each person's paying the $2 plus their portion of the $6. So to find that, all we take is the total cost divided by the number of people. So 10 divided by 2 equals 5. 14 divided by 4 equals 3.5. And then 26 divided by 10 equals 2.6. Okay, so notice the cost changes. As the more people in the vehicle, you're going to pay less. Each person pays that $2 still, but you're splitting $6 between a lot more people, so you'll have a smaller amount. Okay, it says how might you determine the entrance cost for a bus with 50 people? So we're going to assume that bus is still $6. Each person is still $2, so we're just going to multiply 50 times 2 and then add 6 to that. So you'll get 106. Okay, it says, is the relationship between the number of people and the total interest cost a proportional relationship? Explain how you know. So no, this is not. And the reason is right here, right? If it was proportional, our y value here divided by our x value would always give us the same value. Well, the first one gives us 5, the second one is 3.5, and then the third one is 2.6. So that value continually changes. So therefore, it can no longer be proportional, or it can't be a proportional relationship. So our y divided by x does not equal the same for each value. Okay. So it says, what equation could you use to find the total entrance cost for the vehicles with any number of people? Well, we can set that up as y is our total cost. And we know that our total cost comes from $2 times the number of people. So x will be the number of people in this case. So 2 times that plus our $6 entrance fee. So that gives us the equation for that table. Notice how it differs from a proportional relationship, because instead of just a y equals k times x, we have this additional plus 6. Okay, so that's the change between a proportional relationship in a table and a proportional that's the difference between a proportional equation and an equation that's not a proportional relationship. All right. This next one, 7.3, running laps. Okay, Han and Claire were running laps around the track. The coach recorded their times at the end of each lap, 2, 4, 6, and 8. Okay, so we need to find the minutes per lap. So this would be our constant of proportionality, or what we're finding to see if there is a constant of proportionality. This is going to be our y divided by our x, where time is y, distance is x. So 4 divided by 2 equals 2. 9 divided by 4 equals 2.25. 15 divided by 6 equals 2.5. And then 23 divided by 8 equals 2. That would be 7/8, so that would be 875. Notice how these change, therefore they are not proportional. Okay. All right, now Claire's run time. So minutes, same thing. You're going to do your y divided by your x. So 5 divided by 2 equals 2.5. 10 divided by 4 equals 2.5. 15 divided by 6 equals 2.5. And 20 divided by 8 equals 2.5. Okay, this one now is a proportional relationship, because she is running the same speed no matter how many laps she's running. Okay, and so that just answers this one. Is Han running at a constant pace? No. His minutes per lap changes. Based on the number of laps he's taking. Is Claire's? Yes. Hers is, because she has a constant speed no matter how many laps she runs. All right, and then the last question here that ties to that. It just says, write an equation for the relationship between distance and time for anyone who is running at a constant speed. Okay, so remember the form of a proportional equation is y equals k times x, where k is your constant of proportionality, or the constant speed someone's running. We're going to switch out y because it says in relationship between distance and time. So time is going to be our y value. Okay, and time is going to equal the speed the person's running. So in this case, it'd be 2.5. And then you're going to times that by d, the number of laps they run. All right, so Claire was running 2.5 minutes per lap. And so to find her time, you just multiply the number of laps she runs and that will give you her total time. Okay, and this will work, say if somebody's running it a lap in 2 minutes, you just put t equals 2 minutes times d, and so on.